Hello, and welcome to today's webcast, Tools for Data Exploration. My name is Chuck London, and I will be hosting today's event. We would like to answer questions that arise during the broadcast. Please do use the Q&A panel to submit your questions at any time. However, we may wait until the end of the presentation to address your questions. Ross Matusalem is going to be the presenter today. And we'll take care of a couple of house cleaning items before we kick it over to Ross. As you hopefully can see on your screen, we just want to highlight that there are going to be some upcoming JMP academic webinars. If you would like to attend, or if you know any others who would be interested, please have them register at jump.com/academic-webinars. If you need any help learning JMP, the JMP academic program does offer free workshops and one-on-one consults for university teachers and researchers. If you're interested or know anybody at your school that would be interested, please have them contact us at academic@jump.com. Also, if you need any materials for your course, the JMP academic program offers free teaching materials, including case studies, sample data, video tutorials, and more. For access to these materials, please visit jump.com/teach. Now I'd like to introduce Ross Matusalem. He's an academic ambassador at JMP, and he'll be doing today's presentation. Welcome, Ross.
Thanks, Chuck, and sorry for the delay there, everybody. My Zoom looked like it had frozen up on me, but I think we're good to go. Chuck, you can hear me okay?
Absolutely. Absolutely.
Wonderful. Everybody, thank you for coming. Before we get started, I'll just remind everybody, as we've had a number of people join in about the past 5 seconds, please do submit any questions that you have at any point during the presentation. Please just use the Q&A panel, which looks like this little speech bubble box in your Zoom interface, and that will help us keep track of all the questions. So with that, I'm going to get started here in JMP on today's topic, which is tools for data exploration. So we often collect data for our research and have specific questions or goals in mind, specific tests that we want to run, specific types of models that we'd like to build. But I think we would all agree that before we get into running hypothesis tests or building models, there are some real basic, more exploratory questions that we should ask ourselves. And I have those questions listed in this JMP journal on the left here. First off, what data do we even have? We probably have assumptions about the contents of whatever data table we're working with, but it's often, or really always, a good idea to verify those assumptions and to make sure that the data that we have are what we expect. We also need to ask ourselves if the data are suitable for analysis. Whether we need to know whether we have outliers, whether we have missing values, if we meet certain distributional assumptions. These are a couple really foundational things to address before we actually get started with the analyses that we plan to do. And then, of course, sometimes we actually collect data not to run targeted tests or build specific models, but really to explore for relationships between variables to help us better understand the domain in which we're working and maybe help us even generate some research questions to begin with. So right now, we're going to look at JMP tools to answer these 3 broad questions. What data do we have? Are the data suitable for analysis? And what patterns are in my data? We're going to cover a lot of tools right now. So our main goal is to raise your awareness of the tools that are available to you and how they work at a relatively high level. And then if you are in need of a deeper dive in any of these tools because you have a strong use case for them, perhaps in your own research, the JMP academic team can help you get to know these tools in a greater level of detail here. So let's dive on in to the first question here what data do I have? Question that we should start with every time we open a new data table. And to get a little more specific, when we're asking this question, I argue what our real goal is to just summarize our data numerically and visually. And so let's take a look at a few tools. As you'll see throughout today, I'll say some, but certainly not all of the relevant JMP tools for achieving this goal, for producing numerical and visual summaries of our data. So we're going to take a look at this data set to start off. This is a data set of various indicators across 69 of the world's largest cities. This is a data set I found online recently, provided by the New York City Global City Database. So we have our 69 cities. We have various indicators, for example, geography, information on population, the economy, and so forth. And so certainly when I downloaded this data set the first time, the first question I had is, well, what data are even in here? And so the place to start, whenever you ask yourself this question in JMP specifically, I would say is right in the data table itself. And by that, I don't mean looking at the individual values. I mean the header graphs that you can see at the top of the data table right here. So these are actually showing you visually and in one instance numerically a quick summary of your data. Taking a look at your data before performing any analyses is so foundational that with JMP we build it right into the data table itself. So here, take for example the header graph for the country variable. We can see that we have the most cities from China, and then next from Germany and the United States. Or the continent variable, we have the most countries from Europe and then from Asia, followed by North and South America. And the header graphs are interactive. So if we right off the bat want to find any of the data associated with what we're seeing, all we have to do is just click right on it. So for example, I've clicked Asia here, and now I have the data for all of the cities in Asia. Actually see that I have a couple hidden and excluded rows, which I didn't mean to happen. So we'll go ahead and get rid of those right now. Now you can actually see that United States is the most common country in the data here. So if you looked then to the right of where we just were, you can see that we have continuous variables with histograms and the minimum and maximum values shown for each. So for example, we can see a highly positively skewed distribution for the city and metro area measures that are in kilometers squared here. If you don't see header graphs in your data table when you open JMP, there are two possibilities. One, they're just hidden. So this little bar, 3-bar icon is how you reveal them. So I can click on that to hide them and bring them back. And if you don't see that little bar icon, it means that you're working with JMP 14 or previous. The header graphs are introduced in JMP 15. So if you do have a subscription or an annual license for JMP, just know that that comes with all upgrades to the most recent version. So if you're working on JMP 15 or earlier, you have the ability to upgrade here because right now we are at JMP 16.2. So the header graphs, they are what we would call, I guess, just quick and dirty visual summaries of our data. And so let's take a look at what I would say is kind of the tabular or numerical cousin to this. So that is a quick and dirty numerical summary. And we can get that with a tool called the columns viewer, which I know from the survey at the beginning, we have a number of people who are intermediate or maybe even expert JMP users. And I found that talking with folks that have used JMP for a really long time, this is actually a tool that not a whole lot of folks realize is there. So I'm going to go to the columns menu and select the columns viewer. In the interface, we just select the columns that we want to summarize. So let's go ahead and just select all of them. And then in the summary, I'm going to specify that I want quartiles when I summarize my continuous variables. Then I'll just click Show Summary. So what I have here is a single table that provides a brief summary of every column that I just specified. So let's just take the very first column, city here. Well, I can see that I have 69 observations in the city column, which corresponds to the 69 rows in my data table. So it looks like I have no missing values. Whereas in city area, you can see it says I have 66 observations with 3 missing values. So right off the bat, I can see how many observations I have, whether I have any missing observations or rows with no data. For categorical variables, I can see the number of categories. So here, my city variable has 69 unique levels, which is 1 for each row, which makes sense because I have 1 city per row in my data table. So right off the bat, I can verify things like this. For example, if you had a column that was supposed to be a unique identifier, you've set it to nominal, and then you know that the number of categories should equal the number of rows in your data table. For our categorical variables, that's it. You can see that all of the other measures over here help us summarize our continuous variables. For example, city area, I have the minimum and maximum values, the mean, standard deviation. And then because I asked for the quartiles, I get lower, upper quartile, the interquartile range, and the median. So take this in combination with your header graphs, and you already have a fair bit of information about the data that's in your data table. You can start to verify whether the ranges of the values look correct, whether you have missing values, maybe even more than you would expect, and so forth. So from here, I typically put data into a more robust summary, or a more, I should say, detailed summary of each individual variable. And that is what this next tool is for. And for all of you longer time JMP users out there, I hope that you have made good use of this since you ever started using JMP. And that's the distribution platform, which provides in-depth summaries and enables statistical analyses of individual variables. It's basically your univariate statistics tool in JMP. And if you choose to use the workflow that I'm demonstrating now, where you look at the header graphs, then you head on into the columns viewer, you can get to the distribution platform right from inside this columns viewer. So I'm not going to look at the distribution of the city variable now. We already know that it's just 1 row per city. Let's say that I want to look at, we'll go with the continent. And for now, I just want to summarize the area and population measures. So I'll select those columns in this table. You can actually see, I'll do it again. If you look at the data table in the background there, you can see that the columns get selected as I move my mouse. So I'll select these 5 columns and just click the distribution button. And it takes me right into the distribution platform, which we'll talk about in detail in just a second. But I do want to point out that the distribution platform, being so central to understanding your data, has multiple ways to get into it. In this workflow that I'm demonstrating, we're getting into it from the columns viewer, but you can, of course, find it under the Analyze menu at the very top. And so I could just cast those columns into the Y role here and click OK. That's another way to get to the distribution platform. Or you can get there straight from your data table by right-clicking on any of the header graphs. And if you have multiple columns selected, when you go to open in distribution, it will open all of those columns in the distribution platform. It's so important to take a look at your individual variables before going any further with your data that we try to have many routes to get to this really foundational tool in JMP. So you can see in the distribution platform, if you haven't really spent any time here before, we get both graphical and numerical summaries of our data. So for our continent variable, which is a categorical variable, we get a bar chart, and then we have a table of the frequencies and the what's labeled probability, but really here, that's just the proportion in our data. So you can see that we have 3 cities in Africa, which is just about 4% of our data overall. For a continuous measure like city area, we have a histogram, also a box plot. And then below we have the quantiles and summary statistics that by default include the mean, standard deviation, 95% confidence interval, and a couple other measures as well. So this right here, this default presentation provides a lot of information that allow you to further verify that you have the data that that you think you should have. But there's a lot more that you can do with the distribution platform as well. These graphs, for example, are interactive. For those of you who's jumped for a while, that's obviously no surprise. But for some of the newcomers here, you can hover over any part of a graph, really here in the distribution platform and elsewhere, to get some additional information. For example, I hover right over the bar for Asia. It shows the first cities. It looks like the first 6 cities in our data table that are from that continent. And we also see the N, or the sample size of 24 here. And I can click right on Asia, and it will actually show me the distribution of the data just from the Asian continent across all of our other variables. So I can start to look for patterns that way. Similarly, if we look over at our box plots, we see some potential outliers. So in this case, particularly high values in either area or population. And these are interactive as well. And we're going to spend a little more time talking about outliers in a moment, but just to highlight, for example, a couple things you could do, just hover right over. You can find out which city in this case is that outlier. So here, the largest city in our data set is Hamburg, Germany. And I do want to point out right now that you'll notice that I didn't enter city into the distribution platform, but it is displaying the city to me. And this is a particularly helpful thing, telling JMP that you want certain information displayed whenever you hover over a data point. If I go back to the data table, you'll see next to the city variable right here, this little yellow tag icon. And that's how you know that city is currently a label variable, meaning that whenever I pop up these hover labels, it should tell me what city the data are from. You can set that just by right-clicking and going to label unlabel. So if I click that right now, actually, it'll turn it off. And you'll notice that if I go back to this point, it no longer tells me what city it's from. So when you're initially exploring your data, I highly recommend turning on the label feature for any column that would be particularly informative to you. It's pretty clear here that anytime I take a look at a data point, I would want to know what city I'm talking about. So I turn that labeling on. So when I'm working with the distribution tool, I often want to make some additional adjustments to provide the information I need to vet my data. Just to show a couple examples of that, the bar charts here for our nominal variables by default don't actually have along this horizontal axis the counts here. So these are really just relative heights, but they don't tell me the absolute counts. So I might go to the histogram options here and ask for a count axis. And now that axis is supplied for me. Maybe I actually don't want the quantiles presented. So what I'm going to do is go up to the red triangle next to this continuous measure, and I'm going to go to display options and turn the quantiles off. One thing to know about JMP when you're engaging in data exploration, sometimes you have a report like this where you want to execute the same command across all the variables you're looking at. So maybe I want to turn all the quantiles off. You can broadcast commands in JMP. So I'm on a Mac. I'm going to hold down the command key. On Windows, you'd hold down Control. So I'm holding that down right now, even though you can't see me do it. And if I now go to the red triangle and deactivate the quantiles, it gets broadcast across all of these. So that's a nice little time-saving tip there. Now, similarly, I might want to add some additional summary statistics. There might be specific statistics that you always want to see with respect to each variable. So I could, and again, I'm holding down Command to broadcast this, go to the red triangle next to summary statistics and customize them. Maybe I don't want the standard error, and instead I want the minimum, maximum, and median always displayed to me. So I'll click OK, and you can see all of those have been added to the summary statistics tables. So there's a wide variety of statistics that you can request to help better summarize your data for your purposes. Know that if you want, you can actually set which statistics appear by default by just going to the preferences. I won't demonstrate that right now. It's pretty straightforward. You just go to JMP preferences, or if you're on Windows, file preferences, and then set the preferences for the distribution platform to include the statistics that you want. Okay, so a couple of other things we may want to do when we're looking at our data is, while they are really analyses, they're more exploratory statistical analyses. For example, If I'm going to do some modeling with a particular variable, I might want to check to make sure that it meets certain distributional assumptions before getting started. The distribution platform is great for that as well. Let's actually see what distribution best fits this city area variable. So I'm going to go to the red triangle and go to continuous fit. And now I can fit any number of these continuous variables. I'm actually going to go to fit all to just ask JMP to fit all possible continuous distributions to this variable. And it looks like the winner, the best fitting distribution, is the log normal distribution in this case. Now, what that means is that really, if I log transform this variable, I should be able to get a good fit using a normal distribution. And that's something that I'll leave you to try out on your own at some point. But you can use these continuous fitters to do that. So that's a somewhat in-depth overview, actually, of the distribution platform. Hopefully, for those of you who've been using JMP for a while, maybe you've seen a couple things in here that you didn't know about. But again, this is such a foundational tool to understanding your data that I recommend every new data set that you ever get be put into this distribution platform so that you can understand better the data that you have. Now, of course, there are other ways to try to summarize your variables. And for many of us, we like tabular summaries. So what we might call crosstabs or pivot tables. And if you prefer to look at your data that way, or you have use for it, I recommend using the tabulate tool, which you're going to find under the analyze menu, just below distribution and fit y by x. So the tabulate tool, the idea is to make creating tabular summaries of data quick and easy without cumbersome dialogues or having to write any code or anything like that. So let's take a look at some parts of this data that we haven't seen yet. I'm going to go down to the environment variables and let's take a look at the air quality measures. So I might add air quality to my table. You can see I just dragged it right into the center of the table. It lit up blue, and now I have, in this case, just the sum total air quality measure, which of course isn't meaningful. Just the default for a continuous variable in this case is just the sum. So we have this list of statistics on the right that we can use to pull up new statistics, new summaries in the table that we're creating. So actually, I'm going to go with the mean, the minimum, and the maximum instead of the sum. So I'll drag those over and just replace the sum. You can see the little blue box showing that I'm dropping it right on top. And so now I have the mean, minimum, and maximum air quality. Now, the truly good thing about, tabular summary, crosstabs, is that you can break all these measures out by some other groupings or categories. So let's actually take a look at air quality by whether or not a city has enacted local laws or regulations for energy efficiency. So I'll pick that up and just drop it to the left here. And you can see now that when no laws are in place, the mean air quality is 110. But when laws are in place, that drops down to just about 44. And if you're not familiar, lower air quality scores are actually better, more healthy. So it looks like perhaps we see a trend here where these laws and regulations might be related to some kind of improved air quality. Though actually, let's just bring another statistic in there. I'm going to put the number of observations into our table as well. And you can see that there are only 4 cities in our data that specifically state that they have no laws or regulations for energy efficiency. So maybe we have a bit of a small sample issue going here. Now we can really add anything we want to these tables and build out any kind of highly customized table. For example, just one thing I might do is reproduce the simple table that we have for these other environmental variables, like whether or not the city vehicle fleet has been retrofitted or whether the city has a bike share program. And so I can just click and drag this below the table and now have it reproduced, but for the vehicle fleet variable. Click and drag this, and now I have it for the bike share program as well. And so I'll click done. You can see that, while I've spent a couple of minutes talking about this table and how I did it, really it's just a couple quick click and drag movements to create a highly customized tabular summary of my data like this. I can start to see if I'm, seeing any relationships that make sense to me. So when you get—
Hey Ross, really quickly while you're
Sure.
here, one or two quick questions. Is there a way to get p-values into the table when conducting inferential analysis?
JMP provides p-values in a number of contexts. I guess it would depend on exactly what context we're talking about. If we're talking about the tabulate tool that we just saw, that doesn't provide p-values, and that it doesn't perform any statistical tests itself. But in the distribution platform, for example, any hypothesis test you run there would be produced with an accompanying p-value.
Great, thanks, Ross. And then really quickly, is there a way to only show 3 digits for descriptive statistics? Or how would you only show 3 digits?
Yes, so there are formatting options throughout all of JMP's tables where you can set the either a fixed decimal format or the width of the field. So that's just the total number of characters in a field. So for example, if we go back to our tabulate table, I've actually done that in this version of it, which if I pull up our control panel, so I should be more specific. If you remember from before, the means were out to many significant digits, and here it's just to 2. How I did that was click change format, and then down here, in this case, I set the width of 1 to 5. Or of course, I could even say use the same decimal format and say all of them should be out to 2 decimal places and click OK. And now that's been imposed on the table. And so there are options and tools all over JMP to allow you to set the number of significant digits.
Great, thanks, Ross.
Sure. So again, we've been reviewing tools for summarizing your data, some but not all of the relevant JMP tools. These are just 4 that I strongly recommend using, especially the distribution platform. I really do believe that every data set you ever bring into JMP should be put into the distribution platform to help you better understand what data that you have. So let's move on to the second part of today's presentation, and that's all about finding out whether our data are suitable for analysis. And that question can take you in a lot of different directions. We actually already hinted at it a little bit when we looked at the best fitting distribution type for that city area measure. Sometimes we want to make sure we meet distributional assumptions. But for here, what I'm really going to focus on is addressing 2 typical data quality problems, and that's outliers and missing data specifically. So let's talk about some, but not all, of the relevant JMP tools to help address outliers and missing data. And we're actually going to switch data sets now. So I'm going to close down our global cities data, and we are going to pull up the equity data set. This is a sample data set provided with JMP. It's on home equity loans. So we have one variable here, bad, which indicates whether somebody turned out to be a good or bad credit risk when we gave them the loan. We have the amount of the loan that they asked for, and then we have a number of pieces of information from their application. For example, what their current mortgage due is, the appraised value of the home, and credit information like the number of derogatory lines on their credit report and so forth. And so this is a data set that might resemble what one would use in a predictive modeling scenario, trying to figure out what aspects of an application might help us predict whether or not a loan will be defaulted on. But before we would do something like that, we want to assess data like this for outliers that might influence our results and too strongly, or missing values that might indicate that either we don't have enough data to build a reliable model, or that maybe we have some data that's not missing randomly, that we have certain types of individuals who haven't provided us with certain information. So let's talk about missing data first. You can see actually right in the data table here, we have these dots, and that's how JMP represents missing data in a continuous variable like value or mortgage due. You can see here, we actually have just some blank cells for these character-based data, reason and job. But oftentimes we're not going to just notice even the missing data directly in the table. So one of the quickest and easiest ways to find missing data is using a tool called the missing data pattern, which, as it says, it summarizes the patterns of missingness in the form of an interactive data table. So let's see what I'm talking about there. You'll find the missing data pattern under the columns menu, or excuse me, the tables menu. And so we're going to go down to missing data pattern. Now I'll tell JMP which columns I want to assess for missing data. And so in this case, I'm going to put everything but our validation column, which is column we create to use this data set in modeling. So I'll add those columns, click OK. And what JMP has produced here, possibly to some folks' surprise, is another data table. But this data table is both a summary of the missingness in all of our data and a way to interactively select rows in our original data that have some missing values. So here's how you parse this data table. Right here is a representation of the patterns of missingness. So we have 1 digit for each of the columns in our original data table. A 0 says that column does not have missing data in it, and a 1 suggests that it does. So this pattern of all zeros represents all of the rows in our data table that do not have any missing data whatsoever. We can see in the count that that's actually 3,364. And to just confirm, the number of columns missing shows 0, meaning that these are the rows in our data table for which we have complete data. And you can see in selecting this row in our missing data pattern table, I've actually selected all of the rows that have complete data in my original table. Now, for example, if we go to the second row here, you can see I have 883 rows in my original data that just have 1 column missing. And if we look at the pattern, it shows just a 1 right at the end. So that just means the last column has a missing value. And if we look, that's the debt to income ratio. And so now I have, by clicking in this table again, I've selected the 883 observations in my table that are complete except for the debt to income ratio. Now, you might want to do something with these. For example, maybe I'm going to go out and try to find that information to complete these records. One easy way to do that, whenever you have rows selected in your data table, right-click on the selected and go down to Data View. And this will actually pull those up into a separate data table that is linked to the original. So you could go through and start filling these values in, and JMP would modify the original table. So you can see right here, actually, I have the first row selected here, and it's also missing right here. And you can actually enter information, and that updates the main table. It's a handy way to start dealing with some missing data if you can actually go find it and need to enter it manually. So you could spend some time with this missing data pattern table and assess all of the patterns of missingness, find those that are most common. So we've already seen one with 883. Here's another pattern with 125. So this is a good way to assess every type of, or again, I'll use the word pattern, every pattern of missingness in your data. But sometimes we actually want to take almost a higher level view of the missingness in our data. For example, let's take a look at these two right at the bottom. So these are two different patterns of missingness. If you look, one has 10 missing columns, one has 11. The only spot in which they differ is the debt to income ratio column at the end. So up here, it's not missing, and down here it is. So these two are really very similar. You might say that we have 8 rows here where their pattern of missingness is almost the same, except for that one column. And so this is pointing towards another tool that can be very, very useful for assessing missingness. And that's the Explore Missing Values platform, which screens missing data. As we're about to see, it can actually cluster patterns of missingness together. And if we need to, it can perform data imputation. So that is filling in missing data based on a variety of methods. So you're going to find this tool under the screening menu. So let's go to Explore Missing Values. I will go ahead and put all of our columns into the Y columns roll. Now, right off the bat, we get essentially what we saw back in that columns viewer. We had a number missing column in that table as well. So we can see that the loan amount and whether or not the loan was repaid are complete, but all others have some missing data. I can actually click show only the columns with missing to help simplify that table a little bit. Now, what I'm going to do is turn on missing value clustering, which I think is something that is really helpful in understanding whether there might be some higher kind of trend or pattern to the missingness in our data here. So what I have here in this dendrogram is a representation of all my rows on the vertical axis and then my columns on the horizontal axis. Yellow right here is indicating that the data is present. Blue is indicating that it's missing. And so right off the bat, I can just see this big chunk of missing data in my table. It's actually, if I click and select all the rows, we can see that that corresponds to 222 rows in my data table that are all missing all of these variables here. Now, they differ in some of the other variables that they do or don't have, but they all are missing this set of variables. And what set is that? Well, it happens to be the number of derogatory lines on the credit report, the number of delinquent credit lines currently open, the number of recent credit inquiries, the average age of their credit lines, and the number of credit lines that they have. So this is their credit history. It looks like this is 222 individuals for whom we did not, either we didn't pull their credit history or we did, but that data never made it over into our final data set. And this is clearly some kind of pattern where there's some non-randomness to the missing values here that we would probably need to take care of. Now, we're not going to get into data imputation, but this is something that is commonly done in some situations when you have missing data, especially missing completely at random. And so if you go back to the commands, you will notice several options for data imputation that we're not going to get into now, but it's important to know that they're there. So that was explore missing values and then also missing data pattern, two tools for assessing missing data.
Russ, really quickly, how did you get to the explore missing values?
Explore missing values is available under analyze and screening.
Screening. Awesome. Thank you.
Yes, right here.
And then while I'm here, there was one question a few minutes ago. In this equity data table, there's the asterisk beside the bad column. Also looks like validation. They were wondering what the asterisk meant.
Sure. If you see an asterisk in your columns pane in your data table, go ahead and click right on it. And what you'll find is a list of your column properties that have been set. So in this case, we have note associated with it and value labels. Let me just click on value labels and you'll see what we get. You get launched into the column properties and it shows that really underlyingly, that's a column of 0 and 1, but I have requested that in the data table and elsewhere in JMP it display the string good risk whenever there was a 0 in the table and a 1 whenever there was bad risk. There's actually something similar going on with the validation column. So this asterisk just means that there are column properties set. Go ahead and click on it and you can actually see what those properties are. All right, so let's take a look. We just talked about handling missing data. Let's talk about outliers. So as you can see in a couple of these distributions, at least, we'll take a look at value actually. You can see in the header graph that the assessed value of the home goes anywhere from 8,000 and the low end all the way to 856,000 on the high end. And that 856,000 sure is at the very high end of our distribution, of a very positively skewed distribution. We might consider that to be an outlier. That could be a value that if we were to use this variable in a model that could perhaps exert undue influence. So how do we actually find outliers and decide what to do with them? And that's what the Explore Outliers platform is all about. So let's access that by going to Analyze, Screening, Explore Outliers. So what I'll do right now, just for demonstration purposes, is I'm going to take all of these variables and click Y columns. You're going to notice something. It says 2 of the columns were not added to the list. they probably have the wrong data type. And so you can see that actually reason and job were not included. I'm glad that we actually just mentioned that bad underlyingly is zeros and ones. I didn't mean to include that right here. The Explore Outliers platform will force you to use only numerical data because an outlier is really assessed with respect to its distance from the center along some kind of continuous measure. So let's click OK. What we get at first is not a report, but a control window. So we have a couple options for assessing outliers in a univariate sense. So that is just with respect to just a single variable, and then also in a multivariate sense. And we'll talk about that briefly in a moment. But let's start with this univariate outliers. And to do that, I want to draw our attention back to what we saw in the distribution platform. So let's actually just pull up this value variable. So the distribution platform by default produces this outlier box plot, as it's called. So without getting into the details about how to interpret everything in an outlier box plot, suffice to say, we typically interpret anything beyond this upper fence or whisker as a potential outlier. And you can see that that's a fair bit of data here in this home value column. In fact, 318 rows. This is one form of what we would call a quantile range outlier. What it does is finds all values that are a certain number of interquartile ranges, which is actually just the width of this box right here. And it's past some other quantile, often the 75th percentile. And so that's what this represents right here, is that cutoff, the whisker here. So what we can do is actually be more flexible in what we consider those cutoffs to be when we define outliers. So let's just use the default. So I'm going to click quantile range outliers, which you can see we've applied the upper 10% of our data as the cutoff quantile, so the 90th percentile. And instead of doing 1.5 times the interquartile range, we've done 3 times the interquartile range. And we've said, okay, please find for me all values that exceed the threshold defined by those 2 parameters. And so we can look down below and actually see for loan and for mortgage due, we do not have any outliers. For value, we've detected 4 outliers. Okay, so I'm going to click select rows to find those 4 outliers. And you can see that it's actually just these 4 right here. So we've been a little more conservative in what we would declare an outlier. And it seems like perhaps it's appropriate. I mean, these 4 are so far beyond the rest of our data that we might want to perhaps exclude them, or at least keep a close eye on them and make sure that they don't influence our results too much. So just to, again, demonstrate what this is doing, let's imagine instead that our tail quantile was what it normally is in an outlier box plot. So that is the upper and lower quartiles. And we're only going to look at 1.5 times the interquartile range. If I rescan, you can see we found many more outliers. And if I go to this value variable and select the rows, you can see now I've actually selected all of those exactly beyond our box plot here. So I basically reproduced the box plot. So this is just a more flexible way of finding outliers based on some of these cutoff criteria that we can specify. So let's actually get back to where we were before. I'll select just those 4. And now what do I do with them? Well, one of the easiest things to do is just keep track of them, in which case I might say, well, color those rows for me. And now a color has been applied to those points all over jump so that they'll appear in this nice pink that has just been displayed down here, so that I can keep track of them as I'm making graphs and analyses. I know that those are the outliers that I've identified. Now, when we're doing statistical analyses later, unless we have reason to believe that these are errors or somehow data that are not from the population of interest, we might want to include them so long as they don't unduly influence our results, which can often be assessed in part by doing analyses both with and without the outliers to see how much the results change. So in that case, I might want to have a version of this variable where these points are included and a version where they're not. An easy way to do that, and I think this is a lesser known thing in JMP, is this formula columns option in the Explore Outliers platform. So what's going to happen is when I click formula columns, and then it's going to ask me for some name information. I'm just going to leave this as is. You notice I had value selected. And so what it's done is created a new column, in this case called value called, and it's based on a formula. And that formula is saying if the home value is within the range that I've specified, the range of values, then go ahead and leave it in my data as is. But if it's outside that range, that is, it would be considered an outlier, then go ahead and set it to missing. And so I have those 4 data points now where in reality, I have those values, but here they've been culled. So now I have a version of my value variable with the outliers removed without actually having to change anything in my data table here. So this can be a pretty good way to be able to work with your data, potentially accommodate outliers in a more flexible fashion. So there are some additional options in this Explore Outliers platform, in particular with respect to multivariate outliers, which is a little beyond the scope of what we're going to talk about right now. Suffice it to say, a point can be an outlier, not with respect to any individual variable, but only with respect to the relationship between variables. Take this example here. I just have 2 nameless variables, x1 and x2, and they have a pretty strong positive relationship that you can see right here. And this point in red is clearly violating that relationship. This is what we would consider a multivariate outlier. You can see that with respect to the distribution of x1, it's not an outlier. I mean, it's kind of in the upper tail, but not that far. With respect to x2, it's, trending towards the lower tail, but it's certainly not an outlier. It's only an outlier because it violates the relationship between these 2 correlated variables. And to detect outliers like that, you want to use multivariate outlier detection techniques, of which we have 2 here. Again, beyond the scope of what we're going to get into, but I think it's important to recognize that's something to be aware of when screening your data for outliers, and that you have the tools here to identify those outliers and deal with them. So again, when we're asking ourselves if our data are suitable for analysis, that can really encompass a lot of different things. But I think 2 of the most common are going to be screening for outliers and screening for missing data, figuring out what to do about it. And so these are 3 tools to be aware of: missing data pattern, explore missing values, and explore outliers that I highly recommend you get familiar with. It's a good idea for every new data set to run these tools on them, just to make sure that your data are suitable for the analyses that you intend to do. So let's move on to the last section today. And this is one that's truly exploratory, not just getting to know our data so that we can confidently conduct the analyses that we want to do, but instead just when we kind of enter an analysis, maybe without any specific hypotheses, and we just want to find relationships in the data to inform us, maybe help us derive some further research questions. And so our goal here really is to find associations between variables, or as we'll see, another potential goal is to maybe find 1 or more variables that are particularly strong predictors of a response of something we care about. So one tool to use in this case is Graph Builder. And now we talk about Graph Builder all the time at JMP. Most of the people on this webinar right now, I believe, are at least novice JMP users, not brand new. So I imagine you've seen Graph Builder before. But just to provide a quick example of what you can do with Graph Builder, this is just a great way to, in a really kind of ad hoc fashion, just start searching for patterns in your data. So if I pull up Graph Builder here, what I have is a list of all my variables on the left, and then places where I can drop them on the right to build out my graph, kind of like we built out in drag and drop fashion those tabulate tables before. And I realized I just opened I just went back to the global cities data without warning you. So we're back to these data right now. But let's say, for example, that I wanted to look at the relationship between a couple of my continuous variables. Let's say we're going to go with the proportion of foreign-born individuals and population growth, with the idea being that more people who were born outside of the country typically would mean that the population should be growing. So I would expect a positive relationship there. You can see that if I just drag those variables into my graph on the X and Y axes, JMP immediately produces a graph for me. I can make adjustments to that graph using, among other things, this ribbon of options at the top. I'll turn off my smoother and maybe add a density ellipse to help me capture the correlation. Looks like a reasonably strong correlation. I can actually request that directly using this tick box, where over here you can see additional options for the elements in my graph, like the points that are there or that ellipse that I added. I might instead actually just do the line of best fit, essentially run a regression in my graph. If I wanted to see if this slightly positive relationship, though potentially flat, it looks like, seems to hold across other variables, it's pretty easy to do that. I could take, let's say, my continent variable and drag it into my grouping to see what this relationship looks like across each continent, or put it in the overlay to directly overlay all those lines into a single graph. Graph Builder is a really flexible tool that allows you to just drag and drop your variables in order to build out whatever kind of graph might best answer your question about relationships between variables. And again, this is something that we cover so frequently in our webinars and in help materials at JMP.com that I don't want to spend a whole lot of time here. The goal really is to make you aware of this really flexible tool for building graphs to help explore relationships in your data. Now, a few other tools that I think get a little less coverage that are worth being aware of. Sometimes we just want to, we have a lot of continuous measures and we want to find the correlations among all of them. The multivariate platform that we have is a particularly strong tool for this. So we have a lot of continuous measures here. For example, the population measures and the area measures. We might want to know what's correlated with what else, just to help maybe generate some hypotheses about what drives, population change or economic variables or so forth. So under multivariate methods, I'm going to pull up the multivariate platform here. And I'm going to add let's go with the geographic, population, and economy variables. I get another alert saying, hey, a few of these probably have the wrong data type. The multivariate platform runs on continuous variables only. So a few of the categorical ones in those groups were not included. So when I click OK, I get a correlation matrix. So this is every pairwise correlation among all the variables that I put into the platform. And a scatter plot matrix, which is a nice way to help me visualize these potential correlations. I actually like to turn on the shaded ellipses to help me find those a little better. So it looks like, for example, the strongest one that pops out is a pretty obvious one right here. City and metro population tends to be highly correlated, but it actually looks like we also see, for example, a nice correlation among the poverty rate and the unemployment rate. I recommend sometimes when you have a lot of variables and you're using this tool to use the color map on correlations. So instead of a scatter plot, what you have here is actually just essentially a heat map where the stronger correlations are either red or blue for positive and negative. So for example, I can find a seemingly strong negative correlation here between the poverty rate and the share of the top 500 global companies, which might make sense. Big economic drivers in a city might help reduce the poverty rate. So this is a great place to go, this multivariate tool, for assessing pairwise correlations in mass. And it's great for just finding those relationships and also to call back to the other question of whether my data is suitable for analysis. If you're building models and you're wondering about collinear predictors, this is a great place to go to assess that collinearity. Now I see I've run us a little short on time. So I'm going to provide just a very brief overview of these last two tools, two more screening tools we haven't spoken about. yet, but that are really, really strong for finding relationships in your data. I'm going to actually start here because I think this may be the last thing that we get to with response screening. So consider this scenario. So we're going to go to a new data set. This is actually a data set that comes bundled with JMP, and it is with respect to the manufacturing of semiconductors, where people have developed or innovated on a process for semiconductor manufacturing. And we have, in this case, 387 different tests that we run on the semiconductors. Now, this is from an industrial domain, but we actually have a lot of academic researchers in engineering and sciences that work on innovations in places like semiconductor design. And so this would be highly relevant in a situation like that. So we have this new process that we've developed, and we might want to know across all of these different tests or measures that we have about the performance of the semiconductor, which ones were affected by the new process and which weren't. So this is where we would say we have a mass family of tests to run. So in this case, we might want to do 387 t-tests, one for each of these variables. And this is exactly the situation that response screening is for. So let's go to response screening. It lives under the screening menu. I will say that my X variable, in this case, is just the process, new versus old. And then I have our 387 Y variables. I'm going to make a couple changes here and click OK. And JMP has run 387 t-tests and produced a graphical and numerical summary of all of those tests. So what we have here in the numerical summary at the top is all of the tests that we've run, ordered in this case by a transformation of the p-value. And you may have noticed I clicked to do robust estimation in this case, which is just to help reduce the influence of outliers, which we, if you will trust me, would have found if we ran this through the outlier screening. And so basically we have a rank ordered table of all of the test results. And if you notice this FDR, we've controlled for the false discovery rate across all of these tests, meaning that even though we've done 387 tests, we've adjusted our p-value threshold or our alpha appropriately to accommodate the fact that we're more likely to get at least one false positive when we do a lot of tests. So what's typically done after running all of these tests is we can take a few of our most statistically significant results. Let's say we take the top 5 here. And then we actually ask for those analyses. So I just went to the fit selected. And now I have the, in this case, t-test results for each of those top 5 so that we can actually assess what effects we saw. And so the act here of running 387 t-tests while controlling the error rate is just in a couple clicks. And now we have a full output that we could use to better actually understand the results of the significant tests that we found. So I apologize for running us a little short on time. It doesn't look like we're going to make it to predictor screening. Just know this is a really handy tool for finding which factors most strongly predict a response when you have many potential explanatory variables. You're going to find that under the screening menu as well, under predictor screening.